Hello everyone, welcome back to our Homelab video series. So in the previous video, we have the Jupyter Proxmox server setup. We have also configured the DNS, installed NixOS virtual machine by downloading the ISO. We have also configured an NAS NFS volume to use with the templates. And we have configured the virtual machine using terraform. So I have done a couple of minor improvements before starting with our next part. So the first thing I've done is, so if you remember, we had the terraform state in a local file instead of saving it in a cloud environment. So it was not possible for me to push it into GitHub, which would be a security concern for me. So I use something called git crypt. So basically what it can do is, based on certain rules, it can encrypt some of the files before pushing to git and decrypt while pulling it. So it uses your GPG key to encrypt and decrypt. So let me show you how it is done. So if I do git crypt status, it shows that the terraform.tf state and the backup are encrypted and nothing else is encrypted. So there is a git attributes file where I define which kind of files are to be encrypted. So here you can see that everything which ends with the tf state is filtered through git crypt, and git diff is also filtered through git crypt. So this is how it is set up. So all you have to do is git crypt init and then git crypt add gpg user with your email id. Okay, so once you do that, if you see in the GitHub repository, let's say if I go to this folder and try to open the tf state, you can see that it is a raw file because it is encrypted. Okay, so this is the first improvement I've done. The next thing is I used pass to store the secrets. So in the previous video, in the envrc file, we had used the hard-coded credentials for the Proxmox user and password. So we used to have 12345 as a password. So what I've done is I changed the password to something more complex and saved it in new pass. So this is added into this particular path, and with new pass it will be stored as a file encrypted using your GPG key. It's like a password manager but managed locally within your machine. So I have already added the password there, and in the NVRC I modified the command to read it from there. Okay, so every time I'm in the repository in the current folder, the drun will automatically source these two commands and make these environment variables available. So these are the two changes I've done. And also I have renamed the virtual machine to Darkland, and I had to install a few things in this manually, but we will get rid of it when we do the remaining automation. Okay, so continue with today's setup. So the next thing I'm trying to do is to build a virtual machine template. So here, if you remember, we had to attach an ISO file and boot it up, and then so usually how it is done is we attach the ISO file, and then inside you open up the UI console and then install the virtual machine. So the way it is usually done is you create a virtual machine here, attach the ISO file, then boot up the virtual machine, then and install the operating system in the virtual disk. So that's how it is usually done, but I would like to automate it a bit more and prepare a virtual machine template. So in Proxmox you have an option to convert this into a template. So with this you can use this as a template to spin up the remaining instances. So I can do this and use this Darkland itself as a template, which is already quite good, but I would like to get a step further and even automate the creation of templates. So what I mean by that is I would like to create a NixOS based template which is going to have the bare minimum, like just the disk setup, the operating system, and the cloud init template. That's it. So I can use this to spin up all the remaining virtual machine I needed whenever I want, and this template will be stored in the NAS for sure. Okay, so that has to be automated as well, and since I'm using NixOS, everything is going to be declarative and versioned. So that is the first objective of today's video. So I found a really good article which gives us a very good start. So this is apparently not something everybody does. So here, what this guy, Josh Lee, has done is he has declared the virtual machine profile in a configuration file. So those who are not aware of NixOS, it allows us to declaratively define an entire operating system. So if you take this example, you are defining something like the host name, the services you are running, the packages you are installing, the environment variables, file systems. Basically, the whole operating system can be defined as config. And if you don't know yet, I'm using NixOS as my daily operating system. So this whole setup is running NixOS, which you're seeing right now. Okay, so coming back. So what this guy has done is this VM profile has the configuration required for a base template, and then it is used to generate a Proxmox virtual machine image. But remember, this is not a template yet. This is just a Proxmox backup file. So once this is created, we will have to copy it to Proxmox, then spin it up, and then use it, convert it into a template. Okay, so this is a really good start for us, but the only thing missing here is that we will also need to enable cloud init. The reason why cloud init is important is when we spin up new virtual machines using this template, we want to be able to dynamically change the network settings and user data. So if you see here, we have an option called cloud init, and it is disabled because we don't have cloud init drive. So essentially what this means is the operating system is going to run a cloud init service, and it's going to look for a certain configuration file, and we can sideload that configuration file, and inside that file we can define the username, password, public key, IP settings, etc. And when the operating system boots up, it will read this file and adjust its settings accordingly. So this way we can use the same template multiple times, and each time we can specify a different set of configuration. So this is what is used in almost all the cloud environments as well. So the goal is to create a template which supports cloud init so that we can use it as a template for all the remaining virtual machines. Okay, so let's start from here and then build upon this. Okay, so I'm going to copy this VM profile, and then okay, so here we have the terraform code. You know what, let's add this here. So NixOS base maybe. Okay, let's call it NixOS base image. Inside that we need a flick.nix. Okay, so this is the configuration.nix. Okay, so let's look at the configuration. So this is importing the QEMU guest profile. Okay, networking host name, make it as a base. Okay, enabling the QEMU guest, enabling boot drive. Okay, so this is a BIOS boot, so no need of encrypt devices. And enable grow partition, that means we can make the root partition dynamic. And this looks interesting. Okay, so this should be enabled. Okay, so this means the remote users under this group will also be able to do updates. Okay, I don't know if we need this, but I will see. Okay, so we need vim git. Okay, we'll need password equals false. Enable SSH. Okay. Default file system 64. Okay, state version 24 or 5. Okay, I think it looks good. Let's see if we can find a Nix flake for VM. Okay, we can use the NixOS generators. Okay. So this is a Nix flake, so we can use this to pin the dependencies, and so here there should be an output defined, which we can use to generate the virtual machine image. Okay. Perfect. Using a frame. This is a better example. Okay. NixOS unstable. Yes, why not? So it uses NixOS generator. Okay. So it generates one for Linux x84 64, and let's pass the configuration. Format will be Proxmox, and I don't need any of this. Okay. So I think that should be good. Let's start from here and see if it works, and then we can add any additional things as required. So Cosmos, Jupyter, NixOS base image. So let's do Nix build. What is it called? Proxmox. Okay, I need to add this to Git first. So this will make Nix aware of these files. Okay. So it's gonna download all the dependencies and start building it. Let's hope it works. I'm still not sure if I need the DNS for hostname.local addresses. I'd like to keep this as minimal as possible because we'll be using this as a base, and we'll have a separate configuration for each of the virtual machines anyways. Anyway, let's see. If we want, we can use this method to create separate virtual machine images as we need it, like one for Kubernetes, one for, let's say, game server, one for database, etc. That also works. So if you have a simple template that you can use just to deploy it for multiple services, that works. But in my case, I would like to have the bare minimum machine as a template, and then I have separate configuration for each of my machines. Okay, I guess it is done. So we have the result folder. So anyway, so we have this file here. What we need to do is copy this into our TrueNAS. I forgot the location. So this should be in main Proxmox templates. Yeah, we can copy this to the mounted location in Proxmox. So Jupyter templates and FS. So nice. Let's try if this works. Okay, so we have the template there. Let's see if we can see that from the UI. So this should have... Why can't I see the backups here? Is there a different folder for this? Okay, I think it should be in the dump. Okay. Oh, perfect. So we can restore from this. Can we see the configuration? Boot size, cores, ID 2. Okay. Oh, the MAC address is 00. I think this was mentioned here. Okay, so MAC address is 00. It must be ordered through QEMU config, or the unique attribute must be set to true when importing the image on Proxmox. Okay, so let's try to restore this. This will be called VM100. Okay, so make it unique. Start after restore. Nope. Let's increase the cores. Let's increase the memory. Oopsie. One socket, 2 cores. Name can be NixOS base. What do we call here? NixOS base. Okay. Okay, so we have this as a template. So it's not a template yet. We need to convert this into template. But before that, I'm going to clone this and just see how it works. So NixOS test. Okay, so I'm going to use this. So this is a clone from this one, and let's see, same settings. Cloud Init drive is also there. Interesting. I wonder if it takes the Cloud Init parameters. This would be interesting. Let's try. .60 maybe. Let's keep the IPv6 using DHCP or Slack maybe. Okay, we will try if it works, and then if it does, it's good. No EFI detected as expected. Boot in the kernel. Okay. So let's see if the SSH works. Perfect. So we just need to set the private key, sorry, SH public key to be able to log in. So let's stop this. In the cloud init, we will copy the public key again, then set the SH public key to mine and start. Okay, sorry, wrong VM. Perfect. This is exactly what I wanted. Wow. So, thank you, Mr. Josh Lee. Okay, so this is now a perfect candidate for a base image. So I'm going to delete this and I'm going to shut this down and okay, what am I doing? Okay, and then remove this test VM, delete everything, just make sure that everything is correct here. So CPU usage, memory usage, boot disk is not attached, but disk size is 0. So processors, machine, coordinate drive is there. Okay, hard disk 422 megabytes. What is that? Okay, that's interesting. I think we need to adjust that. Then network device and a serial port. Okay, so let's check the diff once again. So we have created the configuration, we added the flake, then we have built everything and copied into Proxmox. Then one thing we missed is to convert this into a template. Perfect. So now we can remove this. Perfect. So now we have this NixOS base as a template. So we will be using this as a base to create all our remaining VMs. Okay. So clone NixOS test full clone. Okay. Maybe let's change it to 4098. Cloud init public key. We config. Let's set it to 192.168.1.60. Okay, let's leave the IPv6 as DHCP. Nope. So we don't need a username or password. Okay, what else do we need? Start boot. Yes. Boot order, no. Okay, so it's going to use the default one. Hot plug is API support. Guest agent enabled. Okay, I think that's it. We can start this. Actually, before starting this, we can do the import. So imports TF. let's use the import block. So in order to import, we need to use the node /type /vmid. So Jupyter /q/101. Okay. Can we change the parameters for the base? That would be interesting. Anyway, so we are going to import the NixOS test into plan generate config out. Okay, so it has generated the config for us. Okay, generated by NixOS. What did we miss? So okay, so we need to specify the cloud init VM here, and virtual disk. Then the network is also configured here. I wonder if we can omit this and let it be auto. Okay, so let's do a bit of a cleanup. So if we do terraform apply, what's gonna happen? So it's not gonna, it's going to change the vCPUs. Okay, this is also fine. Clone wait CPU host. Okay, automatic reboot. Okay, so let's apply this. Has it started? No. So we need to start it. Let's set the VM state to running as well. We're going to clean up all these things in a moment. So VM state is running, and change this to NixOS test. So we can use this file to experiment with the clone. Okay. Okay. Now it should start any moment. Okay. Perfect. So IP config works, and if we check the disk is 4 GB. I think we can change that. And yeah, it works. Now let's try to clean this up. So we can do something like, okay, let's get rid of all the ones which has null. That already cleaned up a lot. Why is the boot parameter space? Let's check the plan. No changes. So CI upgrade. Okay. I wonder if we can get rid of the. Yep. So all this can be removed because we didn't specify it here either. Okay, so I believe, yeah, we don't need the firewall either because we'll have the firewall inside the virtual machine. Okay, and then serial. Okay, we don't need the serial. What else can we clean up? So these all are optional parameters. Boot, what is boot? Okay, that's a boot order. We don't need to worry about that. Okay, full clone is false. And why is that? This should have been true. I guess this will recreate the VM. Let's see. Yes, because we want to use a full clone, not a linked clone. Anyway, it's fine. So we are testing anyways. Memory, hardware, sockets, SSH keys. Okay, VM state is running. And then, so let's change this back and try a few more parameters, because we would like to know what all things we can clean up from here. So let IO disk. So if I change this to, let's say, 30G, what's gonna happen? Okay, it's going to change the disk size. I hope it will work. Let's see if the changing of disk size will work, because that's going to be quite useful. I think since we added this option of, since we configured it to auto grow, so if you remember, we had this option called auto grow somewhere, grow partition. So I think we should be able to dynamically update this size, which is quite good. So let's see, go to hardware, hard disk is now 30, and it's already done. Wow, that's interesting. Let's see. Yes, we had to. Perfect. Okay, I think that's pretty much it. And now we can try to change this to full clone true. So this should just recreate the whole VM and make it as a full clone. I think this is a very good template which we can use to create the rest of the VMs. Yep, good progress so far. Let's go to our to-do list. So we have the VM template ready. So I think this is a pretty long video already, so I'll stop here, and in the next video we will set up the whole game server. So we need to set up the storage buckets, which I'm going to use for doing some backups using Rustic. I will explain that in the next video, and then also set up the monitoring. Then we can dive into NixOS and set up the Valheim game server with your machine.